Hello! This lesson is all about one objective, and that is how to describe distributions of quantitative data. Almost assuredly, you'll have an FRQ on this topic on your AP test, and a handful of multiple choice questions describing this topic. So let's get to it. We generally want to describe four things, and they are shape, center, spread, and anything that is unusual. But that's a lot to remember. So let's rearrange some things here and come up with some kind of clever acronym. Shape, unusual, center, and spread. What's that spell? You got it. Sucks. Now, there are a lot of different variations on this. I've heard SOCS where the U is replaced with an O for outliers, SOCV where spread is changed to variability. But what's the fun in saying that? So let's stick with SOCS. And we'll start by describing shape. Shape is a succinct way to describe trends in a distribution. So let's discuss what would these shapes be. The most common are symmetrical, where the distribution looks roughly the same on either side. There is skewed, where the peak is either to the left or to the right of the middle. And we describe the direction of that distribution based on where it tails off to. So a skewed left is going to have a tail on the left-hand side, and skewed right features a tail on the right-hand side. I can always remember this by imagining, if this were a hill, which direction would I want to ski off of? Now, moving away from skewed distributions, we also have the uniform distribution. This is where every individual takes the same value, or it looks like one single peak or a single bin in a histogram. There's also a description based on how many peaks there are. When you see one peak, that's called unimodal, as in one mode. Remember how mode is the most frequent? Two peaks would then obviously be bimodal. There could be many modes, which you could call multimodal. But we will rarely, if at all, address these distributions in this class. More often than not, if your distribution doesn't look like one of these images, you'd say it's indistinct. Now, you may use one or two of these descriptors whenever you are describing the shape of a distribution. Moving on to U, we have the unusuals. Unusuals represents anything strange in the distribution. These include potential outliers, which would be individuals that are unusually large or unusually small values. We'll worry about how to calculate outliers later. For now, just focus on saying there's a potential outlier at blah, 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 blah. Gaps or clusters of individuals may also be considered unusual, so you can address where those take place, if at all. The nice thing is, if you don't have anything that deviates from the overall pattern of the graph, then you don't have anything unusual, and you don't need to address it. So hey, that's one less thing, and I'll take it. Next is center. Center describes how the typical individual behaves. This might be the mean, median, or mode, but don't use these specific words just yet. We'll focus on using the word typical and trying to identify how a randomly selected individual might behave. Ask yourself, what is the most likely occurrence here? And that's often going to describe your center of the distribution. Lastly is spread. Spread describes the variability, or how each individual varies from each other. For now, you can talk about things like range by examining the minimum and maximum values in a data set. You can also identify if there's a big clump. Where did most individuals land? Spread can be tricky, as it is very relative to the context of each situation, so just kind of roll with it for now. But things like center and spread are best described with calculated values, certain statistics. We're going to cover that stuff in lectures later on. For now, I want you to focus just on your general descriptions unless you're otherwise stated to. Now, you can create a bulleted list whenever you're describing a quantitative distribution. Just make sure you're describing things in context. Moreover, don't be afraid of qualifying language. If something is not quite symmetrical, then say so. Say it's roughly symmetrical. If something is between skewed right and symmetrical, then say it's slightly skewed right. Now let's look at my students' final exam scores as an example to put all of this together. And now we can finally answer my question, did my students perform well on the final exam? For shape, I see a tail on the left-hand side, and the peak is slightly to the right of the middle. Thus the distribution of my student scores is skewed left. Well, what does that even tell me? That actually tells me my students did pretty well. My students scored closer to the maximum than they scored closer to the minimum. I don't see much deviation from the overall pattern in this histogram, but if I do look at the dot plot, I can see that two students scored unusually low. I might also identify the gap where nobody scored between 30 and 37 points, but to be honest, that's not a very big gap, so I might ignore it. For center, I had a large number of students scoring between 50 and 55 points. That's where the peak lies and also where the largest cluster of student scores is located. For spread, without having any more specific calculations to make, I would look at the range. My students score between 13 and 65 points, but the majority of them score between about 35 and 55 points. Now, that's a lot to write. This is where our language of statistics comes into our benefit. Let's summarize in just a few sentences. The distribution of final exam scores is skewed left. There are potential outliers that scored only 13 and 14 points. The typical score was around 50 to 55, with scores ranging from 13 to 65 points. I'm done. That's it. Do you see what I did there? Shape, unusuals, center, and spread, all in context, talking about the individuals as my students and the values as their final exam scores. Remember, talk about what the graph represents, not the graph itself. Lastly, I use qualifying language like potential outliers and around 50 to 55 points. Now you might be worried about those things that I left out, and it seems kind of arbitrary. Your guiding principle should be this: address the key features based on the information that is presented. If all I had to go off was this histogram, I would not necessarily have picked up on those outliers, so I wouldn't have even talked about them. So do your best to address the key features for which you have evidence to talk. And that's it. The best way you can really understand describing distributions is to practice, 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 and check with your instructor if you are uncertain about anything you've written. Just remember SUCS. Describe the shape for trends, unusuals for, well, anything unusual, center for what is typically happening, and spread for the variability, for how the individuals behaved compared to one another. Write those things in context and you will be awesome. That's it for today. Have a wonderful one, and I will see you next time.